building. Okay, and I have also told you that mainly one building consists of two basic components. One is the superstructure and the other one is the substructure or foundation. Now, superstructure means the portion of the building which is above the ground level. Okay, and it is basically the part of the building which serves the purpose of its intended use. And then what is the substructure or foundation then? It is the lower portion of the building, usually located below the ground level, and the purpose of this is to transmit the load of the superstructure to the underneath soil so that the settlement due to the load of the building are within permissible limit without causing cracks in the superstructure, and also the soil does not fail due to shear. Okay, now uh, what is the permissible limit? You know that if the load will be transmitted by the foundation of the building, then obviously if the load is within the bearing capacity of the soil, then there will be no chance of failure. Okay, there will be no chance of failure. But if it is more than the bearing capacity of the soil, then obviously there may be settlement due to the load. Now, all the whenever you will design any building considering the soil condition, then all the soils has some permissible limit of the settlement. Okay, permissible limit of the settlement. For example, for if it is single spread footing, I will explain what is spread footing later. If it is single spread footing on sand, then the allowable bearing pressure is such that the differential settlement should not exceed 1/300 of the 1/300 of the width, and the total settlement is about 50 millimeter. Okay, if it is more than 50 millimeter, then the building will collapse. And if it is clay soil, then the differential settlement will be allowed 1/300, and the total settlement will be allowed 75 millimeter. Okay, so therefore, if the settlement is slight and uniform throughout, then there will be no damage, okay, caused in the building. But if the settlement is excessive or unequal, okay, then serious damage may result. And the damage may be in the form of cracked walls, distorted doors, window openings, cracking of the lintel, then the plumbing system may be moved out from the wall, and sometimes the complete collapsing of the building. Okay, now the
Ma'am, I have one
allowable
question, ma'am.
bolo.
Ma'am, in some buildings, it is seen that the walls become bulgy, as if some accommodation of watery material is over there. So why does it occur in some?
that that is different issue. I Whenever I will discuss damping, then I will tell that
Okay,
damping
ma'am.
as
Okay,
well as plastering. But that bulging in the wall is not the result of the failure of the foundation. Okay.
Ma'am, please let me
okay, ma'am.
join with laptop.
Let me join with laptop means.
Ma'am, I am already doing class with the phone, but I want to join it with the laptop. So I am asking to click. I have clicked on asking to join.
But I am not finding any pending request.
Yes, ma'am. I have been also trying to join
You
for
you you.
last 5 minutes.
But I am not getting. Anybody of you can see? I'm not getting
No,
any
ma'am.
pending request. So you logged off and then again try to log in. Okay.
Yes.
So as I told you that there are some allowable maximum settlement as well as bearing capacity of soil. You just memorize those things. You will learn all those things in detail during the fourth year in the foundation design class. Okay. So, for example, if it is commercial and institutional building as well as residential building, then allowable maximum settlement is 25 millimeter. If it is industrial building, then the settlement allowable maximum settlement is about 38 millimeter. And if it is special machinery foundation, which is of much importance, then allowable maximum settlement is very low, only 0.5 millimeter. Okay. And here also you can see that depending on the type of soil, whenever you will read the soil mechanics in your other semesters, then you will find that soil may be of different types. Okay. uh, for, for example, the coarse sand, medium sand, clay, expansive soil, etc. And here you can see the bearing capacity is highest for the coarse sand and lowest for the expansive soil, around 50 to 100 kilometer square. So depending on the type of the soil, you have to design your foundation so that the load distributed by the foundation should be within this bearing capacity. And due to the load, there will be the settlement under the building, and that settlement should be, এই কে অন করে রেখেছো একটু অফ করো তো, and that settlement should be equal and should be within the maximum permissible limit. So now, then what will be the function of the foundations? Okay. What will be the function of the foundations? The first and foremost important function is the reduction of the intensity of the load of the building. Okay. So the function of the foundation therefore is to distribute the load of the structure over a large bearing area. এই আব্দুল রহমান, তারপরে অমিত মন্ডল, তোমরা কি সব অন আছো?
Yes, ma'am.
স্টুডেন্ট
Hello.
students, please check your mic and mute it. And the second function is evenly distribution of the load. Okay, so that show that if there will be any unequal settlement, then that will be prevented. Third one is the lateral stability. Lateral stability means it anchors the superstructure to the ground to prevent the lateral movement of the supporting materials. Fourth one is the provision of the level surface. So, to provide the level and firm bed for the smooth operation of the building.
The idea?
এই এত ক্লাসে ডিস্টারবেন্স হলে আমি কিন্তু ক্লাস নেব না। Then to increase the stability of the structure as the whole, this is very important function of the foundation. And not only that, the function of the foundation is to provide safety against the different safety against the undermining by different burrowing animals like rats, moles, etc., as well as the flood water. Okay. Now, repeatedly I am telling that if there will be if the load will be transferred by the foundation to the soil, and if that load is not within the permissible bearing capacity of the soil, then there may be the settlement of the building. Okay, and if the settlement is within the permissible settlement of the soil, and if the settlement is uniform throughout the building, then you will not find any stress. Okay, you will not find any stress, or it will not cause any problem to the building. But if the settlement is unequal, if the settlement is unequal but within the permissible limit, then you will find there may be the tilting of the building. Okay, there may be the tilting of the building. Now, if the settlement is unequal and also exceeds the permissible maximum settlement of the soil, then you will find cracks on the wall, distortion of the openings of the doors, windows, cracks in the lintel, as well as complete collapsing of the building. Okay, and foundation, as you know, that is basically present at the below the ground level. So if some problem will create, it will not be observed by the naked eye until or unless it will cause any sign in the superstructure. Okay, and if it causes sign in the superstructure like cracking of doors, windows, or cracking of the walls or lintels, then it is too late to be prevented. So that is why whenever you will design the foundation as well as design, select the type of the foundation, then you have to consider different issues. The first and foremost issues are the you have to consider the load, different loads like dead load, the self weight of the building, then the live load means the imposed load on the building, as well as the wind load, snow load, etc. Okay, wind load, snow load, etc. So the first and foremost thing is to you have to consider the load, and you have to consider the nature and bearing capacity of the soil on which the structure directly rests. Okay, and as already I have told you that if the load will not within the permissible limit of the bearing capacity, then it will cause the unequal or differential settlement. Okay, and what are the why the unequal or differential settlements may occur? Maybe due to the weak subsoil. Okay, due to the weak subsoil as well as shrinkable and expansive soil, then the action of the frost, then excessive vibration due to the traffic, or the traffic, as well as the operation of different heavy machines, then slipping of the strata on the sloping area, etc. Okay, or movement of the ground in unstable areas, as well as the high level of the groundwater table. Now, what is the bearing capacity then? As I am repeatedly telling you that it should not exceed the bearing capacity of the soil. The bearing capacity of the soil is the maximum load per unit area which the soil or rock can carry without yielding or displacement. Okay, the maximum load per unit area which the soil or rock can carry. And what is the ultimate bearing capacity? Ultimate bearing capacity means the maximum load under the base of the foundation that the soil support. Okay, support before failure due to the shear action. Okay, before failure due to the shear action is called the ultimate bearing capacity of the soil. And if you divide the ultimate bearing capacity by some factor of safety, then you will find the safe bearing capacity of the soil. Okay, and the factor of safety that we normally use during the design of foundation is around 2 to 3. Okay, so do you get what is the bearing capacity of soil? All these things you will again read detail in the soil mechanics class as well as design of the foundation class. Up to this, any questions from both A and B section?
No, ma'am.
Now, now let me show you the different failures of the soil due to the shearing action. Okay, there are three types of shear failure of the underlying soil. Okay, the one is the general shear failure, local shear failure, as well as the punching shear failure. Okay, now you know that soils, a structure of the soils basically constructed of the solid soil particle and the solid soil particle and the voids within the soil particle. Okay, now these voids are either filled with the air or water, or air and water both. Now the soil will have two important properties. One is void ratio. Now what is void ratio? Void ratio is the volume of voids, is it volume of voids between the soil particles by the volume of the solid particles. Okay, and this is known as void ratio. This is generally denoted by E. And another important parameter is there, that is porosity. What is porosity? Porosity is the volume of voids divided by total volume. Total volume means both volume of the solid particles plus the volume of voids. Okay. Now the general shear failure basically involves the total rupture of the underlying soil. When the relative density of the soil is greater than 70%. Greater than 70% means, relative density means, as already I have told you, that void ratio means volume of voids by the volume of the solid particles. So relative density means is equal to E max minus E by E max minus E min. That is volume of voids, void ratio whenever maximum void ratio minus the void ratio of the existing condition by maximum void ratio minus minimum void ratio. Okay, so this is the relative density of the soil. Now whenever the relative density is greater than 70% and the settlement of the soil is greater than the 7% of the foundation width, then what happens? The soil on both sides of the footing will be ruptured by the general shear failure, and that soil often pushed up on the sides of the structure. Okay, pushed up at the sides of the structure. So let us consider this is the schematic representation of the building. Okay, so whenever you are constructing the building, so it will provide load. through the, it will basically transmit the load of the building through the foundation to the underneath soil. Okay, to the underneath soil. Now if you draw the load versus settlement curves, okay, load versus settlement curves, then when the load just greater equal to this ultimate bearing capacity of the soil, then the load underneath the soil will fail by the shear. Okay, soil underneath the soil is failed by the shear, and this type, if due to this failure, you will find that there will be the bulging of the soil above the ground surface. Okay, this is your basically ground surface. So here you can see, due to the shear failure, the soil adjacent to the building burst at the top surface. So this type of settlement is known as general shear failure. Okay. Now second one is known as local shear failure. Local shear failure means it involves the rupture of the soil only immediately below the footing, and there are also some bulging on both sides of the footing, but that bulging is not so much significant as the general shear failure. Okay, and this type of failure occurs when the soil is medium dense soil. For general shear failure is occurs for the dense soil of relative density greater than 70%, and local shear failure will occur whenever the relative density is 35 to 70%, and the settlement of the soil due to the load of the building is 15% of the width of the foundation. Okay, so this is the picture of the local shear failure. Here this is the schematic representation of the building. Now when this is the ground level, so whenever the load is transferred to the soil by the foundation, then if if the up to this there will be no failure of the soil, the settlement will be within the permissible limit. But if it exceeds, this is the ultimate bearing capacity of the soil, but if it exceeds this point, then you will find that there will be the chance of the failure of the underneath soil due to the shear. Okay, and along with this failure of the soil in the due to the shear, you will find that there will be the bulging of the soil adjacent to the building. Okay, now this bulging is not so much distinct as like the general shear failure. And third one is the local shear failure. Okay, local shear failure, sorry, punching shear failure. This will happen only for the loose or soft soil. Okay, where the relative density is less than 35%. Here you will not find any sign of the bulginess at the ground surface. Okay, it will immediately collapse. It will immediately collapse. Here you can see, without going to the ultimate bearing capacity, it will immediately collapse due to the shearing failure. This type of failure you will is known as punching shear failure, and you will not, since you are not getting the any sign of the bulging, so you will not get idea that when whether there is any shear failure in the building or not, sorry, under the building or not. So this is very critical case. Okay, this is very critical case. So in this slide, actually, I have tried to show you the three types of shear failure that will occur due to the construction of the building with different types of loads in the different types of soil. Okay. Now here you can see that due to the excessive settlement of the due to the excessive settlement of a building, sorry, excessive settlement of the soil, the collapsing of the building. Here you will see that these are the picture of the punching failure, punching shear failure. Okay, and this is the picture of the local shear failure. Now if the settlement is excessive, then the building will completely collapse. Okay, the building will completely collapse. So বোঝা গেল why the design of foundation is so much important for the civil engineers. Faulty foundation design can result in lots of problems, and you sometimes you may not understand until or unless you will get the sign in the superstructure. And whenever you will get the sign in the superstructure, that is too late to be prevented. Okay. Okay.
Yes, ma'am.
Now let me explain you the types of foundation. The foundations are broadly classified in two groups. One is shallow foundation and one is deep foundation. A foundation is known to be shallow whenever the depth, let us consider, this is the schematic representation of the foundation. Okay, this is the this is the ground level, this is the load. Now this is the width of the foundation. Okay, this is the width of the foundation, and this is the depth of the foundation. Now whenever this, sorry, the d by b ratio, the depth by width. Okay, the d by ratio, the depth of the foundation by the width of the foundation is less equal to 1, then according to Tarjagi, that foundation is known as shallow foundation. Okay, and whenever this depth by breadth ratio is greater than 1, that foundation is known as deep foundation. Okay, now the shallow foundations are again divided into different groups like isolated footing, combined footing, strip footing, strap footing, and wrapped foundation. And the wrapped foundation Deep foundations includes the pile foundation, pier foundation, and caisson foundation. Now, what is shallow foundations? As already I have told you, whenever the depth and breadth ratio is within 1, then it is known as the shallow foundation. And along this, the depth of the foundation is usually less than 3 meter from the ground surface. Okay. Now, then I have also told you that the shallow foundations are classified into the isolated footing, combined footing, strap footing, mat footing, etc. Now, what is isolated footing? This is the picture of the isolated footing. Okay. Whenever any footing is used to support an individual point load from a column, then they are known as the isolated footing. Here you can see that these foundations are carrying the individual load for a particular column, isn't it? So these are known as the isolated footing. For a particular column, there is only one foundation. Okay, and they may be square, rectangular, even circular, and they may be of uniform thickness, maybe maybe stepped. Here you can see stepped reinforced concrete footing, and here you can see the sloping. The upper surface is sloped one, and the lowest portion is the rectangular one. Okay, solid one. So these are the example of the isolated footing to carry the load of a single column to the soil. And these types of footings are generally used whenever the load is not very excessive and the bearing capacity of the soil is high. Okay. Now, second one is the combined footing. Whenever whenever a single footing is constructed to support two or more columns, they are termed as combined footing. Okay. Whenever the single footing is constructed to carry the load of two or more columns, then it is known as combined footing. Here, if you construct the isolated footing for each column, then the difference, the distance between the two footings are less. Okay, so it is beneficial for the construction purpose as well as the economic purpose to construct two isolated footing for separate column than to construct one single footing. Okay. Okay, and whenever you have to design the combined footing in such a way that the center of gravity of the loads of the two columns is same as the center of gravity of the footing itself. Okay. Okay, and whenever and these combined footings are of two types. These combined footings are of two types. One is the whenever the same combined footing, the combined footing carry the loads of the columns carrying same load. Okay, here the loads carried by the columns are same, q1 and q1, both are q1. So therefore this type of footing is rectangular combined footing. Okay, rectangular combined footing. And whenever the combined footing carry the loads of the columns bearing the differential loads, then to make the center of gravity of the footing and the load of the and the center of the load in a single line, in a single point, the footing is the trapezoidal in nature. Okay, trapezoidal in nature. Here you can see that the q2 is greater than q1. And sometimes you will find that the combined footing is for not only for the columns but for the walls also. Okay, are also for the walls. So such combined footing, this is the combined footing of both columns and the walls. And here you can see that the columns carrying the equal loads. Okay, here columns carrying the equal loads. And this footing is for both carrying the loads of the columns as well as the wall, and here the load of the columns are different. Okay, loads of the columns are different. So therefore this is the trapezoidal type of combined footing for both the columns and the walls. বোঝা গেল? হুম?
Yes, ma'am.
Now strip footing. Combined footings, I discussed you, is to carry the load of the 2 or 3 or 4. Okay, maximum generally combined footings are constructed up to 2 to 3, carrying the loads of the 2 to 3 columns. Now whenever the foundations are constructed to support a line of loads, either due to a load bearing wall, or if a line of columns need supporting where column positions are so close that individual isolated foundations would be inappropriate, then without constructing the isolated footing, a strip foundation is constructed. Here you can see this is the construction of the strip foundation. Here you can see these are constructed to support the loads of a series, a number of series of columns. And this is the elevation of the strip foundation, and this is the plan of the strip foundation. And there is another type of footing which is known as strap footing. Okay, strap footing. Now if the independent footings or isolated footings of two columns, here you can see that isolated footings of two columns are connected by a beam, it is known as strap footing. This footing may be used where the distance between the two columns is so large that a combined footing becomes quite narrow with high bending moments. Okay, here you can see one column carrying the small load and Q1, and another foundation carrying the large load, that is Q2. Q2 is greater than Q1. Okay, now if so, therefore, you have to construct the combined footing of trapezoidal shape. Okay, combined footing of trapezoidal shape, but the distance between the two columns are very large. So, if you construct the combined trapezoidal footing, then it will become quite narrow with high bending moment. So for this case, therefore, without constructing two separate footing, isolated footing, here the without constructing the combined footing, here two isolated footings are constructed. Okay, and here you can see that one column is eccentrically loaded. One column is eccentrically loaded. So you cannot construct the isolated footing uniformly. Okay, this is eccentrically loaded. It is concentrically loaded footing with the foundations, but it is eccentrically loaded footing with the column. Okay, because maybe here there is the boundary line. So therefore, instead of constructing the combined footing, two isolated footings are constructed, and that footing are joined by a beam. Okay, joined by a beam which is not contact with the soil. Okay, which is not contact with the soil. So therefore, this beam This beam, which is also known as the strap beam, is is not in contact with the soil. So it is not carrying the load to the soil, and it is infinitely steep. Okay, it is infinite. This beam is infinitely steep. So what is the purpose then? The purpose of this footing is therefore to equalize the load of the two columns. Okay, it is used to distribute the weight of either heavily or eccentrically loaded column footings to adjacent footings. Get it? Hmm? বোঝা গেল? It is not transferring the load of the foundation to the soil. It is basically equalize the load of the two columns to the foundation, to the adjacent footing. বুঝলে?
Yes, ma'am.
Then finally, the wrapped foundation. This is also known as spread foundation. Isolated footing is for the is transferring the load of a single column. Combined footing is to transfer the load of multiple column, generally two to three column. And strip footing are transferring the load of the columns in a series, columns or walls, columns in a series or walls. Okay. Now, and these type of foundations are constructed whenever the load bearing capacity of the soil is quite high. Now, if the load bearing capacity of the soil is less, or the load of the building is quite high, then to then to reduce the load of the building, the wrapped foundations are constructed to spread the load from the superstructure over a large area. Okay, normally the entire area of the structure. Now, whenever the if you find that if you want to construct the isolated footing for different columns, if it exceeds the 50% of the total area of the building, if the area of the footings exceeds the 50% of the total area of the building, then instead of constructing the isolated footing, this type of spread footing is constructed. Okay, this type of spread footing is constructed. Here you can see that all the footings are connected by the supported by the beams, and then this is supported by a slab. Okay, it is supported by a slab. This type of foundation is also known as mat foundation, and therefore the load of the building will be distributed throughout this slab to the underneath soil. So this is the basically elevation of the raft foundation, and this is the plan of the raft foundation. These red marks are the basically the sign of the columns, and these columns are joined by the beams. Okay, joins by the beams, and above the beams there is a slab. Okay, there is a slab. So therefore this will uniformly distribute the load of the superstructure within the permissible limit of the bearing capacity of the soil. Okay. So these are all about the shallow foundations. Now come to the point deep foundation. Deep foundations, as already I have told, whenever the dB ratio, the depth of the foundation to the width of the foundation is greater than 1, that is known as deep foundation. And there are different types of deep foundation like piles, piers, caissons, wells, etc. This is the example of the number of piles. Okay, whenever the load of the building is excessive, whenever the load of the building is excessive, as well as the soil underneath the soil adjacent to the footing is of very low bearing capacity, then to transfer the load to a deep area, the pile foundations or deep foundations are constructed. Okay, and if it is required to support the load of a particular pier, if more than one number of piles are required to construct, then above that number of piles a cap is constructed. Okay, a cap is constructed known as pile cap, and above the pile cap the pier is constructed. Then above the pier is larger diameter pile and of small depth. And then above the pier cap is constructed, and above the pier cap, the actual building is constructed. Okay, so this is the layout of a deep foundation. Now, as already I have told you that pile foundation is one type of deep foundation in which the loads are taken to a low level by means of a vertical member which may be made up of timber, concrete or steel. Okay, and it is relatively long and slender member, less than 2 meter, less equal to 2 meter diameter. And pile foundation may be adopted instead of the raft foundation when you will not find any bearing strata at the at adjacent to the building. Okay, so by the pile foundations, the load is to transmit through a soil strata of low bearing capacity to deeper soil having high bearing capacity. Okay, for example, let us consider this is the um, this is the this is the picture of the footing, but the this is the ground level, now the bearing capacity of the soil, sorry, bearing capacity of the soil near to the ground surface is not so high to support the excessive load of the building as like mat foundation or isolated foundation. And if you find that there is a soil strata of high bearing capacity at a long depth, then instead of constructing the isolated footing or wrapped foundation, the pile foundation is constructed. Okay, the pile foundation is constructed. Now, pile foundations are classified into different groups based on functions, based on materials used for the construction, or based on the method of the construction. So, pile foundations are categorized into different groups based on the function, based on the materials of the construction, and based on the method of the construction. Now, based on the functions, the pile foundations are of different types like end bearing pile, friction pile, compaction pile, tension or uplift pile, anchor pile, fender pile, seat pile. These are the classifications of the pile foundations based on the functions, and based on the materials made materials by which the piles are constructed are wood pile, steel pile, concrete pile. Concrete piles are again of two types. One is one is plain concrete. Plain means reinforced cement concrete. and another one is precast pile. And if the pile is made up of two or more materials, then that pile is known as composite pile. And by the method of construction, the piles are classified into two groups. One is driven pile and one is board pile. One is driven pile and another one is board pile. And both the driven pile and board piles are classified in two groups. One is cast in situ, pile or precast pile. Okay, okay. So বোঝা গেল what is the pile foundations and what are the different types of pile foundations?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Now, let me explain you the different types of pile foundations based on the functions. Okay. For example, first one is end bearing pile. So from the name itself, you can understand that the load of the building is carried by this type of pile and then it is transferred to the soil by its end tip. Okay, by its end tip. So these piles are those which are driven. These are the driven pile. Okay, which are driven into the ground until a hard stratum is reached. These piles do not support the load, but they basically transfer the load to the stratum which has high load bearing capacity. Okay, so these piles can carry the load through the soft soil or water to a suitable stratum by means of these end bearing shoes. These are end bearing shoes. Okay, so the load of the building, let us consider this is the soil, this is the ground surface. Okay, this is the ground surface and the soil adjacent to the ground surface is less shape bearing capacity. So therefore these piles carry the load through this soil of low bearing capacity to the soil of high bearing capacity, and then finally transfer the load through this end bearing shoes. Sometimes there may be detachable shoes or sometimes there may be non detachable shoes. Okay, now this type of foundations also may be cased or uncased. Maybe cased or uncased. Cased means first what happens? These are the driven piles, as already I have told you that these are the driven piles. Okay, so what first one casing. You can see these hatched portions. These are the casings. Okay, first the casings are driven within the soil up to a height to the soil with large bearing capacity. Then that casing are provided the reinforcement. Then the casing are provided reinforcement. And with that casing there is detachable bearing detachable shoe, cast iron shoe. Okay, this is known as detachable cast iron shoe. So first the casings are driven, then the reinforcement are provided, and then the concrete mixture is poured within the casing. Okay, concrete mixture is poured within the casing. Now if the casing itself if the casing itself will act as the mold of the concrete, concrete is a semi-solid material. So if this mold is if this casing is used as the mold to hold the concrete, then it is known as with casing. Okay, with casing. And example of this with casing end bearing pile is known as Raymond pile. One of the example is Raymond pile. This is with shoe and this is without shoe. Now there is another type of pile which is uncased pile. Okay, which is uncased. This is with casing cast in situ. Cast in situ. And it is uncased cast in situ pile. That means first the casing will be driven, okay, to make the hole. Casing is provided, then with a detachable iron shoe. Then the reinforcement will be provided. Reinforcement will be provided at the place. Then the semi-solid concrete will be poured within the casing. Okay, semi-solid concrete will be poured in the casing, and simultaneously the casing will be withdrawn. Casing will be withdrawn. So the adjacent soil will now act as the mold. Okay, adjacent soil will act as the mold, and so therefore there will be there will be no casing. The soil will be act as the mold, and there may be detachable shoe by which the soil will be the load will be transferred to the soil. The reinforcement will be there. The soil will act as the casing, and the casing made up of metal will be withdrawn. Okay, this type of pile, end bearing pile, is known as uncased cast in situ pile. And example is simplex pile. Okay, example is simplex pile. বোঝা গেল?
Yes, ma'am.
Then friction pile. Friction piles means whenever the load of the building are not only carried by the tip of the pile, not only carried by the tip of the pile, but the surface friction also carry the load of the building. Then that type of piles are known as the friction pile. Okay, whenever the piles are constructed, when the piles are constructed through the coarse sand, coarse dense sand. Okay, so therefore the adjacent soil will provide the friction, to the pile whenever they will be constructed. So the load of the pile not only be carried by the by the end by the end soil, but also the soil through which the pile is constructed, that also carry some of the loads, and that also support some of the load by the frictional force. So this type of pile is known as the friction pile. Okay. Friction developed between the sides of the pile and the surrounding ground support the load of the building. Third one is the compaction pile. This type of piles are not to carry any load. Okay, are not to carry any load. This is the example of the compaction pile. These piles are not carrying any load. A minute. They are used to compact loose granular soil, soils. Whenever the piles are driven through the granular soil, then it will compact the adjacent granular soil, and therefore the bearing capacity of the soil will be increased. Okay, bearing capacity of the soil will be increased. So therefore these piles are not carrying any load. They are basically increasing the bearing capacity of the soil. So therefore the piles can be made up of weaker material like bamboo, bamboo sticks, timbers, etc. Sometimes, first the hole is created by some timber or the bamboo stick, and then that holes are filled with the dense sand. Okay, and then one pile cap is constructed above this. Pile cap is constructed above this. Okay, so therefore they are not basically supporting the load of the building, but by this compaction they are increasing the bearing capacity of the soil, and therefore that soil can now utilized for supporting the load. Okay, this is compaction pile. And tension piles, they are, you know, that piles are generally compression piles because they are carrying the compressive loads. So, but sometimes whenever the piles are constructed to resist the upward forces, due to the hydrostatic pressure or due to the overturning moment, then that type of pile is known as the tension pile. Okay, that type of piles are known as the tension piles. Now, another types of piles are there, that is anchor piles. These piles are used to provide anchorage against the horizontal pull from seat piling wall or other pulling forces. Here you can see that there are different types of piles. This is the original foundation pile. Okay, these piles are to carry the compressive load of the building. This is the foundation pile. Then seat pile. Seat piles are basically the not to support the, not to carry the load, but it will act as the retaining wall. Okay, it is act as the retaining wall constructed adjacent to the soft soil or some water structure. This is the example of anchorage pile. This is the example of batter pile, and this is the example of the fender pile. You just see the picture, I will define all those things. Now, what is fender piles? Fender piles are basically used in the water structure. Okay, are used in the water structure when these are used to protect a concrete deck or other waterfront structure from the abrasion or impact caused by the ships or barges. Okay, this is this is to protect the deck of the deck to by the action of the ship of barges. Then batter pile. Batter piles, here you can see that all the piles are vertical. Okay, all the piles are vertical. But here you can see, here you can see that these piles are constructed with some inclination, and they are provided inclination to resist large horizontal or inclined force due to the action of the different types of ships, barges, etc. In these, all these piles are basically used for the construction of the water structure. Okay, construction of the water structure. Then seat pile. This is the picture of the seat pile. As already I have told you that these piles are not provide any vertical support to the load. Okay, but basically act as the retaining wall. They basically retained the load, horizontal load, due to the storage of the soil, or maybe the or to protect the erosion due to the river water, etc., to isolate foundation from the adjacent soil, or it will increase the bearing capacity of the soil by confining the soil. Also, it will give protection against the undermining action of the flood water, as well as the burrowing animals like rats, moles, etc. Okay. Okay. বোঝা গেল? What are the different classifications of the piles based on the functions? Hmm?
Yes, ma'am.
Then another type of pile, this is typical type of pile. All these piles that I have shown here, they are driven pile. Okay, driven pile maybe cast in situ or precast. Okay, maybe cast in situ or precast. But under dream pile are specific type of pile. They are basically board pile as well as cast in situ. Okay, board pile as well as cast in situ. First, let me show you the picture of the pile, under rim pile, then I will explain. This is the picture of the under rim pile. Okay, here you can see pile means one vertical slender member. Okay, vertical slender member, but along with this vertical slender member there are the bulging portion adjacent to the slender portion. Okay, basically এরকম দেখতে, এরকম দেখতে, ঠিক আছে? This is single rim, this is multiple rim pile, this is double ring pile, this is multiple rim pile, etc. Now, why this type of bulbs? These are also known as bulbs. Okay, why this type of bulbs are provided? Basically, to provide proper anchorage and neglect the effect of swelling or shrinking of the soil. Okay, so this is a specific type of pile which have which has the bulging intrusion within the pile stem at certain specific lengths. So this is the stem of the pile. These are the stem of the pile. These are the stem. These are the stems, and these are the bulging portion of the piles. Okay, these are the bulging portions of the piles, and adjacent to two bulges are there are stems. Okay, and where this type of piles are used? The piles are used for the expansive soil. Okay, expansive soil which has large swelling effect or shrinkage effect. Okay, large swelling or shrinkage effect. Now, to protect the or to overcome this swelling and shrinkage effect, the stems are bulged at certain height. Okay, this type of piles are known as under rim piles. And this what are the expansive soil? Example of one of the expansive soil is black cotton soil. বোঝা গেল under rim pile? These are the rims, and the rims are underneath the soil, and instead of that they are same as the common pile, only to provide anchorage against this expansive against this swellingness or shrinkage due to the expansion or shrinking action of the black cotton soil. Some extra inflammations are constructed with the slender member. So this is known as underrim. And
Ma'am, all
depending,
these are the deep foundations used in
all
deep
are deep
foundation.
foundations, yes, deep foundations. But this is pile foundation also. That means they are carrying the load from from the ground to a deeper surface where there is a soil strata with high bearing capacity. Okay, but since the adjacent soil is expansive in nature, okay, it is expansive in nature, so to provide the proper anchorage against this expansion or shrinkage, in some portion of the stem are are enlarged. Okay, and that is known as rim. There may be single rim, there may be double rim, or there may be multiple rim, depending on the bearing capacity of the soil as well as the load of the building. বাকিটা একই. Okay.
Okay, ma'am.
Yes, ma'am.
Then the well foundation. This is another type of deep foundation that is generally provided below the water level for bridges when the foundation is subjected to large lateral forces. As already I have told you that piles are also deep foundations, but it is large slenderness member. Okay, large slender member with diameter less than 3 meter. But whenever you have to construct any structure in the water, okay, in the water, then to support the lateral forces due to the water, you have to construct the foundation with larger dia. Okay, with larger dia. So, or if the bearing capacity of the soil is very less, but the adjacent to the building, but the load is excessive, then you have to construct the foundation with larger diameter. So this type of foundation is known as well foundation. And this type of foundations is very common from the ancient time. Okay, ancient time. And for example, different Roman structures or different Mughal structures like Taj Mahal are constructed above the well foundation, above the well foundations. And well, the construction of well foundation are quite similar as the construction of the simple well for the abstraction of the water. Okay, if it is underneath the water, if you want to construct the well foundation for the bridge, okay, for the bridge in the water body, then what you have to do, you have to, there is water, so you have to first construct a coffer dam. Okay, construct a coffer dam, and then you have to pump the water from within the coffer dam, within the coffer dam. Okay, and then immediately you have to construct the well foundation. And a certain portion of the foundations you can construct in the bank, and then it will be taken to the place where you want to construct the foundation. And here you can see, and whenever you will provide the load Here, whenever you will provide the load, here you can see that the well foundation consists of the cutting edge. Okay, well foundations constructed of cutting edge, made up of steel or made up of some metal. Whenever you will provide load, it will first cut the soil, and then whenever it will reach the desired level, it will settled at the desired level. Okay, and then you have to construct the bottom plug. This is known as the bottom plug. Then the bottom plug will, this is the hollow structure. Hollow structure show the bottom plug will be sealed, and then the well staining. This is the stain. Okay, well stainings are constructed, and that well stained are filled by the medium sand. Okay, up to the desired level, and then above the water level you have to construct the well cap. So the whole portions will be sealed now. At first it was hollow. First, these portions are taken to the place where you want to construct the well foundations, and it is allowed to sink uniformly. And it will cut the soil. This cutting edge will cut the soil, and ultimately, whenever it reaches to the desired soil strata, then it will settle, and then you will start to construct the stain. And at first the bottom portions are sealed, okay, by concrete, which is known as the bottom plug. This is hollow structure at first. Then the stained portions are filled with the medium sand, and you have to fill it up to the distance above the water level, maximum water level, flood level of the river. Okay, and above the flood level of the river you have to construct the well cap. So now the whole structure is sealed. Okay, then you will construct the pier, and above the pier you will construct the pier cap, and above the pier cap you will construct the original superstructure of the bridge. Now, well foundations are of three types. One is open cation or well foundations. It means cations means box type structure. Okay, cation means box type structure. Whenever the top and bottom portion of the well are open throughout the construction, then it is known as the open question or well. At first it was hollow, it was empty throughout the construction. Now after constructions they are filled, and then the original superstructure of the building or bridge is constructed. So well foundation is the example of a open example of an open cation. Then box cation. Box cation means it is open on the top, however close on the bottom. Okay, here I have shown you that whole portions are open. It is hollow structure. That hollow structure are uh, casted at the C2, but it is open structure at the top but close on the bottom. So it is first cast on the land and then towed to the site. Okay, where it is sunk onto a previously leveled foundation base, and after then it is filled with the medium sand and up to the flood water level, and after then it was plugged by the well cap. Okay, this is box question. And third one is the pneumatic question. Pneumatic question is consists of a working chamber at the bottom of the question which is kept dry under water under pressure. This is working chamber. Okay, this is the example or schematic representation of the pneumatic question. So it is kept dry under water under pressure, thus allowing excavation under dry circumstances. Okay, you have to excavate the area to place the foundation up to the desired level, and that is done by this working chamber with the cutting edge. Okay, this is the pneumatic question. So the question foundations are of three types. One is open question or well foundation. Second one is the box question. That means the bottom portion is plugged initially, and then after placing it the desired level, the top portion will be filled. And third one is the pneumatic question. Here the there is a dry working chamber which is responsible for the cutting of the soil up to the desired level. Okay, and the classifications I have told you are based on the method of construction as well as the method of construction. Now depending on the shapes, okay, depending on the shapes, the cations or well foundations are of different types like circular, rectangular, hexagonal, octagonal, twin circular, then double rectangular, then double D shape, then double hexagonal, double octagonal, etc. Okay, these are the type of the caisson foundations or well foundations based on shape. So this is all about today's class, all about the foundation of the building. So you can now ask me if you have any question.
Ma'am, load bearing capacity and ultimate load bearing capacity, there are difference.
Load bearing capacity means ultimate means the load where the rupture will occur. Okay, the maximum bearing capacity where the rupture will occur, that is the ultimate. Okay, and before less equal to all the bearing capacity or the bearing capacity of the soil, and if you divide the ultimate bearing capacity by the factor of safety, then it will be the safe bearing capacity of the soil.
Ma'am,
Okay.
before the crack occurs, can we identify
হ্যাঁ,
that there is a different bending moments at different
সেইটাই তো
parts of the
বলছি,
house so that yes, is that
সেটাই তো আমি
picture.
বারবার বলছি, that is very important. The design of foundation is very important for you because it is the underneath the soil. So until or unless you will find the sign in the superstructure, you will not understand whether any failure occurs or not. Okay, for example, the punching failure I have shown you. দেখো, যদি if it is general failure, then you will find the sign of the bulging of soil. Okay. If it is local shear failure also, a little bulging of soil you can also observe adjacent to the building. But it is punching shear failure, you will not find anything. Suddenly you will find that there is crack in your building. ওকে, সাডেনলি তুমি দেখতে পাবে তোমার বাড়ির মধ্যে ক্র্যাক হয়েছে। So whenever it will
Ma'am, in building planning class,
building planning class,
ম্যাম স্যার বলেছিল কি যদি ঢুকে যায় তাহলে crack will only proceed up the lintel portion. Then it will stop there.
আরে এগুলো তো
ম্যাম অমনি করে বোঝা যাবে না?
অমনি করে বোঝা যাবে মানে আমি বলতে চাইছি তো যতক্ষণ না whenever you will not find any whenever you will find any sign in the superstructure, it is quite late. Okay, it will cause crack in the lintel, it will cause crack in the wall, it will cause the tiltation of the building, it will cause the displacement of the doors, even it will cause the displacement of the plumbing system also. কিন্তু সেটা করা মানে এবার সেটাকে রিপেয়ার করা ইজ কোয়াইট ডিফিকাল্ট। সো সেই জন্য ইউ হ্যাভ টু whenever you will design the building, you have to design the foundation very carefully so that these type of situations will never occur. You already can provide a certain amount of settlement, na? You can allow settlement up to 25 millimeter for the residential building, you can allow settlement of 38 millimeter for the industrial building. You design it allowing this settlement, but if it is more than that, then you will find the sign in the superstructure and it will quite late to rectify. আর কিছু?
Ma'am, then it is if tilting or uniform settlement happens, then it is easy to rectify.
টিল্টিং হলে দেয়ার উইল ইউনিফর্ম সেটেলমেন্ট হলে খুব বেশি দেয়ার উইল নট সো মাচ প্রবলেম, অনলি তোমার বাড়িটা উইল বি সেটেল টু সাম এক্সটেন্ট। ঠিক আছে, ফর এক্সাম্পল খুব সোজা কথা বলছি, আমাদের সিভিল বিল্ডিং গুলো আগে অনেক উঁচুতে ছিল। তোমরা জানো আমি প্রথম দিনে ফার্স্ট ডে আই হ্যাভ টোল্ড ইউ দ্যাট দেয়ার শুড বি এ গ্যাপ বিটুইন দ্য ground surface to the top to the ground floor. তোমরা কোনোদিন হয়তো এখনো কেউ অনেকেই ডিপার্টমেন্টে আসোনি, দেখবে যে আমাদের ডিপার্টমেন্টের সামনেটা মানে প্রায় the entrance is the level of the ground and some portions are beneath the ground level. Okay, that is not due to the excessive settlement, that is due to the increase of the soil. Okay, increase of the soil level of the road side.
হ্যাঁ, বাইরেটা
Okay,
ঢালাই হয়ে গেছে বলে উঁচু হয়ে গেছে।
হ্যাঁ হ্যাঁ, but if it is occurred due to the settlement of the soil, then what happens, তোমার বাড়িতে water ঢুকবে, first thing is water, then lots of insects, snakes that will occur, and these are and even আরো যদি excessive settlement হয়, if uniform settlement, then this type of things will occur, but not such problem, only this type of problem. But if it is tilting settlement, then it will cause the crack in your different components of the building, and if the crack will excessive, then obviously your whole structure will collapse. বোঝা গেল?
Yes, ma'am.
So that is all.
So, ma'am, will you send this PDF today, ma'am? There's some things that I couldn't note down in time.
I already told you that every day I am sending you the video lecture, but I will not send you any
Okay, ma'am.
PDF.
Okay, ma'am.
এক সেকেন্ড, এখন আমার অ্যাটেন্ডেন্স নেওয়া হয়নি। এই ক্লাসটা বেরিয়ে যেতে পারো, তোমাদের ক্লাসে নিয়ে নিয়েছি।
ম্যাম সেকশন বি কে মিন করছেন?
হ্যাঁ নিচ্ছি, দাঁড়াও।
ওকে।